are Units 8, Worksheet 6, predicting single replacement reactions. If A is a metal, it kicks out the B part. If it's a non-metal, it kicks out the C. Number 1, H2 is our answer. Number 2, LiCl. On the back, Ga2O3. Let me put the charges. And remember, we're using the charges to figure out what the subscripts are. And then for the lone element, we look to see if it's diatomic or monatomic. Okay. Mg is +2, -1. The diatomics are the Hofbränkels. Okay, a lot of people had questions about number 6, so let me spend a little bit of time on that. Lead is on the part of the periodic table where we don't know what the charge is going to be, right? It's one of those ones in the center here. Well, it's underneath the staircase. So we might think it's +4, but it's not always +4. So we have to check. So everything in the center here, other than aluminum, zinc, and silver, and I would also say gallium is usually +3 also. All the rest of them we have to figure out. So lead is with chlorine. Chlorine is -1. There are 4 of them, right? So that total is -4. The total for the positive side has to be +4 because they have to equal 0. There's only 1 lead, so it takes the entire positive charge, and so lead is +4. When it's together with iodine, iodine is also -1, right? It's here. So we need 4 iodines. Any questions about that one? Okay, that was where most people had questions about that yesterday, so I wanted to go over that. All right, here aluminum is +3, oxygen is -2, so we need 2 and 3. And then iron is not a diatomic, so it's just by itself. Okay, questions about those? Good with that? Okay, all right, let's move on to double replacement reactions. Some note paper. If you could take out your yellow note paper from yesterday, if you have space, right on that. If not, there's a new sheet passed out to you. If you don't need the new sheet, we'll collect those at the end, okay? And we're going to talk. We're in Unit 8. And we are predicting products of double replacement reactions. And today is the 8th, 9th. All right, so we're going to start with the pattern. Remember, you have A and B are together, so double replacement has 2 compounds. Right, where single replacement has one compound and 1 single element, but double replacement has 2 compounds. And then they're going to switch partners. So A and C will swap partners. Okay, so now A will be with D and C will be with B. Now, we don't write BC, we write CB because of the charges, right? So we know that the first element is always positive, bless you. The second element is always negative in ionic compounds. So A would be positive, so it's going to be attracted to D because D is negative. It won't be attracted to C because they'll repel each other because they're both positive. Okay, and then C is positive and B is negative. So we don't know what their charges are because they're just made up, but we know that they should be positive and negative. So positives, let's make a note here, positives attract negatives, and the positive is always written first. Okay. Sometimes double replacement seems a little easier than single replacement because there's no single element to check to see if it's diatomic or monatomic. You're just using charges, okay? So you only have to focus on charges. So use the charges to write the subscripts, just like we did in single replacement for the compound. Okay, so let's start. Start with sodium hydroxide, and let's put that together with barium sulfate. We go through this on our periodic table, we'll find that sodium is right here and it's +1. Hydroxide is in the parentheses, so that means it's a polyatomic ion, so we're going to look on the back, and it's right here. It's -1. Barium is in group 2, so it's +2. Sulfate is another polyatomic ion, so we'll flip it over. We'll find it back here, and it has a charge of -2. Okay. So these both, we only need one of each because their charges are the same. Now remember that the cations, the positive ones, are going to switch places. They're going to swap out. Okay, so now the sodium is going to be with the sulfate, and the barium is going to be with the hydroxide. Okay. So our pattern here, our A, B, and C, D becomes A, D plus C, B. Okay, so just switching out that pattern. And then next we have to think about the charges. So it's +1, and then sulfate is -2, and we can go ahead and put that in parentheses. Okay. If sodium is +1 and sulfate is -2, we need to fix our formula to make it equal 0, so we're going to need two sodiums to equal 0. And then for the other compound, barium is +2 and hydroxide is -1. So again, we're going to need 2 of the hydroxides to make it equal 0. Bless you. Bless you. Okay, how's everybody doing with this? Do you want to see one more? Yeah? Okay. Let's think about this. So we've got Mg3P2 plus lithium oxide. Let's do that. Okay, so this is our A, this is our B, this is our C, and this is our D. And then also while we're over here, let's go ahead and figure out charges so we can confirm what everything's going to be with. Magnesium is +2. Phosphorus is -3. Lithium is +1. And oxygen is -2. Okay. So over on the other side, we'll have magnesium. What will magnesium be with?
Oxygen.
It'll be with oxygen, yes. That's our D, right? So we'll put that together. And then our other positive ion will get written for, oh, this is supposed to be a plus. I'm sorry. That's a plus, not an arrow. So lithium, what will lithium go with? Phosphorus. Okay. All right, so we have our rearrangement done. Now we have to think about charges, right? So I'm going to take the charges that I wrote over here and figure them out over here. +2, -2. Do we need any subscripts here? No, because they're going to be equaling 0. +1, -3. Do we need subscripts here? Yes. So we need a 3 right here. Now, we started off with 3 magnesiums, so is this balanced? No, we're going to probably need a 3 here to start with. That gives us 3 oxygens. So I'm going to need more oxygens, right? I'm going to have to put a 3 here to get 3 oxygens. That gives me 6 lithiums, so I have to put a 2 here. So now I have 6 lithiums. Let's check. Now we also have 2 phosphoruses, which we have over here. All right, so balanced, 3 magnesiums, 2 phosphoruses, 6 lithiums, 3 oxygens. All right, can I do one with a Roman numeral with you? Okay, or like one of the transition metals, because I think those are always tricky. Let's do Cr2O3 plus so chromium oxide with sodium sulfite. Okay, this is our A, this is our B, this is our C, and this is our D. The chromium is right here, so that means we don't know what its charge is, right? So we have to figure that out. Remember, when we have one of the transition metals, we have to look to see what it's with to figure it out. And so it's with oxygen, and oxygen has a -2 charge. There are 3 of them, so that totals to -6, right? Our positive side has to be the same, but positive, so +6, and there are 2 chromiums with that charge. So what's the charge on each of the chromiums? If it has to total to +6, yeah, and there's so that it's that +6 is split amongst the 2 of them. Okay? All right. So now we know those. Sodium is always +1. Sulfate we did before, it's -2. So let's go ahead and rearrange. We're going to put A together with D, and we're going to put C together with B. So A is chromium, D is sulfate, C is sodium, and B is oxygen. Then I'm going to write the charges above them that we did from the other side. +3 -2, +1 -2. And then if this is a +3 and this is a -2, each of them is going to have to equal 6, so we'll need 2 chromiums and 3 sulfates. Okay. Don't change anything inside the parentheses, just put the 3 outside. Sodium is +1, oxygen is -2, so we're going to need 2 sodiums to make that be neutral, equal 0. All right. Do you think you can do some on your own now? You ready to work on your own? Okay. I'm going to pass these out. You know what? I'm going to just take 6 for your row, pass them over. I'll get the rest on the end, okay? Thank you. All right.